So in this segment, we'll continue our discussion of life cycles, and we'll get a little bit more into the IC 62304 standard and its definition of the various steps in the life cycle process. So this is figure 1 from the standard. I understand it's small on your screen. We'll zoom in a little bit. But this gives you a sense of the steps involved. And the most important part of any medical process is that we start with customer needs and end with customer needs satisfied. Okay? That is the process that we follow. We figure out what our users need, our customers. We work through a whole bunch of steps with the ultimate goal of satisfying those needs. We're not creating what we feel we need. We're creating what our users need. So if we zoom in a little bit into this document here, into this flowchart, there is this long row here in the middle, which is the subdivision of section 5 of the standard. And this tells you the steps. So we have development planning, requirements analysis, architectural design, optionally a detailed design for classes B and C. And then the second half, software unit implementation verification, software integration testing, software system testing, and software release. So these are the steps involved in this process. And then embedded in this, if you read carefully, if you could zoom in, you'll see this process of risk management. This goes all the way across because the risk management happens at every part of the process. If you look at the standard, there's a similar picture for maintenance. I'm not showing it. I'm still showing figure 1. The maintenance life cycle is very similar to the actual development cycle. The only difference is that the first 2 steps, the development planning and the requirements analysis, get replaced. So development becomes a maintenance. So instead of having a development plan, we have a maintenance plan. And instead of having requirements, we do an analysis of what modifications will change. But essentially, maintenance is a very similar process to the actual creation of the software. And this is an important point, even though we're not going to spend a lot of time talking about maintenance in this class. We'll touch a little bit about it, talk a little bit about it at the end of week 10. It is a very critical part of the process because if you think about it, software actually lives in the maintenance mode a lot longer than it does in the original design. And if you remember back from the original FDA discussion, 80% of the problem with software happen in an updated release, in the maintenance phase, not in the original design phase. So maintenance is an important process. For the most part, though, it's beyond the scope of this introductory class. So we'll have a little bit of a discussion of it, but keep that in mind. So the other thing so far, if you're listening to discussion, you say, well, I hear this word Agile. My classes, perhaps in the computer science department, have told me that all this waterfall stuff is outdated and we're into this Agile space. So how does Agile fit into this process? For those of you not familiar, this is the Agile Manifesto. It's a document that was written about 20 years ago. And let's just read it. It's an interesting short document, and then we'll discuss it a little bit. So they go, we are uncovering better ways of developing software by doing it and helping others to do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. So you can see what they don't like. They don't like processes and tools. They don't like comprehensive documentation. They don't like contract negotiation, and they don't like following a plan. And we're going to come back to the next slide because if you think about it, those are the things that the standards seem to think that you need. That is, while there is value on the item on the right, we value the items on the left more, and you can see the full list of signatories at the bottom. Now, Agile was developed as almost in reaction to old-style software development. It was very waterfall-oriented, very detail-oriented. A lot more time was spent creating documentation than actually coding, and people felt that this was slowing the process down. So a lot of modern software development you will see in industry will follow some kind of Agile process. However, the question always comes up, how does Agile fit with this very detailed process model that we see in the standards and in the regulatory guidance? So let's talk a little bit about that now. So let's focus on 3 of the statements from the manifesto. They value individuals and interactions over process and tools. And I would say that's fine so long as we have process and tools in place as well. They value working software over comprehensive documentation. And again, if you're spending 99% of your time doing documentation, obviously there's a problem. However, in the medical world, you still need documentation. Remember, if it wasn't documented, it didn't happen. So long as this does get interpreted as, we only value working software, we don't care about documentation, you can use Agile and you'll be fine. They value responding to change over following a plan. I think this is a little bit more problematic, but essentially the way around this is to say, well, our plan has to be kept up to date. So if we find something that means that our current plan doesn't work, we have to respond to the change by changing our plan. There's a very interesting guidance document from the Association for the Advancement of Medical Instrumentation, the AMI, that maps the steps in IC 62304 to the steps of an Agile process. So first, before I get into it, just as an aside, the Agile process gets divided into 4 big levels. So at the bottom level, there is a story. A story is a feature that we want to implement. It could be something like, as a user, I would like to be able to annotate medical images. That is a story. The stories get grouped together in increments. This is the work that would be done in a fixed amount of time. Increments get grouped together into releases. Releases are the things, the finished, semi-finished piece of software that get handed out to users for testing and for feedback. And finally, a project consists of a number of releases until, as one of the pictures in the standard goes, we are done or we ran out of money. That's kind of the definition of what the release is and how many releases you go through. So let's look at this. So we have a story down there. And if you will look very carefully, you see this 5.1 to 5.7. These are actually steps in the IC 62304 lifecycle. You see, we use the steps within each story. And then at the end of the story, we do integration testing and we do system testing to complete an increment. So that's the next big thing. And then for each release, we repeat the back end of the testing, integration testing, system testing, and release. These are the back ends of the lifecycle, and we release a version. And this whole thing is grouped together into a project. So at the beginning of a project, we do the planning, the requirements analysis, and the initial design. But then, of course, this design and all of these things will be updated as we go through the system. There's an interesting Agile test case. This was a case study from Abbott Molecular, and this was the development of one of the software for one of their systems there. So Abbott Molecular Diagnostics Divisions adopted Agile techniques for their M2000 project. So the way they did it is that they had fixed and short duration iterations, 4 to 10 weeks, and delivering functional software each time. They use a lot of automated continuous build unities and integration. And these are the hallmarks of these Agile processes. There's a lot of automated processes that people use as part of it. They had daily team meetings. These are often short. This could only be 15 minutes. They had high visibility of status and promoting collective ownership. And again, Agile is often as much a social process as it is a software process. And they did retrospective assessment at the conclusion of each iteration by key stakeholders. They would ask questions. And what they discovered is that compared to what they expected, that these reduce your duration by 20 to 30%. There was a gain here. Now, one can come up with counterexamples where using Agile actually slowed things down, but just to give you an illustration. The waterfall model, just to reiterate the point before we leave this segment, is an idealized model. It's not realistic because we rarely understand all the requirements up front. And intermediate prototypes are extremely useful. We talk to our users, we think we know what they want, but in the best possible circumstances, we'll build a quick prototype and use it to understand the requirements better. Maybe when they use it, they will understand what we think they need, and we'll get some feedback and proceed. And to explain this process, we have a quick segment from Dr. Saratwa Sarkar, who will tell us a little bit about his experience in industry.
The waterfall cycle is what I call an idealized model. In an ideal world, that would be great if you understand all the user requirements at the beginning, and then sort of all the processes flow from there on, like a waterfall, like a cascade of waterfall. But that's not how it kind of usually works in real life. From what we've seen, we usually have moving goalposts in a real life situation where you have like a lot of iterations where you are continuously doing releases, usable releases. And that's where sort of the Agile framework comes into the picture, where you have like a lot of iterative cyclic loops through the entire process, and not sort of the linear waterfall kind of a process that we usually talk about, actually.
And as we will discuss in the remainder of this lecture, the next lecture, while you make every possible attempt to understand the user needs, sometimes even writing them down doesn't help. And the initial prototype, the initial release, the user say, well, this will never work because. So an Agile process allows for that feedback to happen early enough in the process so that you can fix it, as opposed to after you're done completely and now it's too late. So that's the advantage of it, of being able to do these iterative processes. So as a final slide, regardless of what process you operate in, you have to maintain design controls discipline. This is back from the FDA guidance, the vocabulary. We must operate under control. So for example, if during the implementation we find a problem with the design, the right way to do things is we stop the implementation, we fix the design, and then we resume the implementation. We do not continue with the implementation and make an on-the-fly decision without updating the design. We'll fix the design later, but let's just fix the code. And this is important. We must operate under control. This is how we ensure safe software. This is what it means to be operating under design controls, which is the quality regulation process. So with this, we come to the end of this discussion of the standard and the medical software lifecycle. In the next segment, we'll take a quick break and talk a little bit about our example project, the image-guided neurosurgery, which we'll use as a test case to illustrate the concepts in the next couple of weeks. Thank you.